L3 out in VXLAN AVPN. We have 3 leaves to switch, and I would like to give VTAP addresses for our easy usage. The VTAP address, I want to call it as alpha here, beta, gamma. There is no need of VTAP address on S1, S2 because the tunnel never gets ended there. It's not a tunnel endpoint. But we use router IDs, so let that router ID. Anyway, that is not in here considered. They also have loopback addresses. Now, about the bump traffic, we saw there is increased replication. That's one method, but it is not scalable. So we use BGP's control plane in order to forward the bump traffic. Whether it is unicast or bump traffic, they're all in single tenant. Here also we are going to see single tenant, but members are in different VLANs. Members are in different VNIs, which we called as layer 3 out. For example, I have a computer A here, computer B, another computer C. Now A and B are in same color, you see, which means this is VLAN 100, this is also VLAN 100, but this is VLAN 110, not same VLAN. The communication between these different VLAN, which are mapped to different VNI. For example, for VLAN 100, the VNI is, let's say, 1001. For VLAN 110, it's 1110. All right, so different VNIs. Now, according to leaf 1, B, according to leaf 1, B is connected to same VNI and it is behind L1, sorry, L2, behind L2. And according to leaf 1, C is in different VNI behind L3. And according to L1, A is same like VNI B and local via, maybe if it is Ethernet 1, it will show Ethernet 1. Now this type of table will be there on every leaf. Only difference is for leaf 2, B will be local. For leaf 3, C will be local. but they know the whereabouts of all other hosts in this table. What is asymmetric L3 route? L3 out. Asymmetric. If you see the VXLAN header, see we got E1 interface, no? That is where this A is connected, isn't it? Local, right? See, this table is according to leaf 1. This table is the table of leaf 1. If I need to draw leaf 2 or leaf 3, in this, how it will be. According to leaf 3, A is behind L1. C is local. If this is Ethernet 5, then it is E5. Understood, right? I didn't draw the table for L2, but you will know what to do, what it might be. Now, if I want to communicate between A and C, the original source is A, and the destination is C. This is getting encapsulated. Let's say A is communicating to C. Now, VXLAN is going to encapsulate. Now, what is the VXLAN ID? If C is the destination, if C is the destination, and L1 is the leaf which is generating the traffic, what will be the BNI here? This one, isn't it? 1110. But originally the source is from where? 1100. And now the source leaf is L1 and destination is, instead of saying source leaf is, source is alpha, VTEP address, destination is gamma. Now destination is gamma. The underlay protocol like OSPF or ISIS knows how to reach gamma, isn't it? It uses the routing table and it uses the advantage of ECMP in class architecture, delivers the packet to gamma. After reaching gamma, you see it enters only to this domain, 1110. You may have many other VLANs and VNIs on leaf 3, but it exactly goes only to this VNI member group. There it finds destination C. According to this table, C is on E5. So the packet is delivered. This is also L3 out, but this is asymmetric. Why? We call it as asymmetric. See, in class architecture, you got ECMP, no problem. The path it is taking to go will also be the same path via which the reply will come. because they use the VTAP address which has got ECMP. But what if I don't have class architecture? What if I have VXLAN EVPN in a service provider environment? Okay, now this will be like an internet, isn't it? And this may be in Asia, this may be in Central Africa. So packet may go like this, and it may come some other way. We call this as asymmetric, which is not acceptable in most of the WAN communication. That is why we have another method, symmetric L3 out. Now, did you understand asymmetric L3 out? You understood asymmetric very well now? Okay. Next is symmetric L3 out. Let's see how to do that. Symmetric L3. In symmetric, Cisco supports this. You will have, see, these are all L2. What do you see in this table? These are all L2. So there will be an L3 VNI, let's say 5555, which is also distributed in VXLAN updates. Now, if you see, the same scenario, C is talking to A. What will be the VNI? It is L3 VNI. Because it is different network. A and C are not in same network. You see different VLANs. So immediately, instead of putting this number, what? 1110, instead of putting 1110, it puts 5555. For 5555, only the underlay is going to care about. 5555, go to gamma. Now the traffic goes to gamma, and in gamma it looks for destination C, delivers the packet. Now the return traffic, if you notice, C will be responding to A, that's what we call as return traffic. Tunnel address is gamma going to alpha, but the VNI is saying. Now how to reach 5555? I'm sorry, how to reach alpha using VNI 555. The VNI never changes because you have one common L3 VNI on all the switches. The path taken will be same. The going path and return path will be same. If this number changes, the path is not guaranteed to be same. If the VNI is same, the path to and fro will be same, symmetric. This is the reason why in Cisco, when you do the lab, you had L3 VNI. This is the part which you did not understand, correct? In order to have the same return path, if the VNI number is same, before sending, actually according to the destination, the VNI number of the source, the VNI number of the destination is not same. Source is 1100, destination is 1110 while going A to C. When you have something like that, the destination is 1110. For the return traffic, the destination will be 1100. So the path taken is not guaranteed the same. In the non-class architecture. So to have the same path, same as going, the return traffic to come back, you need same VNI for communication between different VLAN member. For that, we choose one common L3 VNI. So whenever a leaf want to send to different VNI, it will simply put this L3 VNI. Any switch you take, they will always put this 5555 only. As a result, because the ID is same, the path taken will also be same. So we have a VRF context called tenant1, where we define that layer 3 VNI, using which two different VNIs can communicate to support symmetric communication. Updates to be exchanged with a unique ID. We need a route distinguisher, which will provide a unique ID for each tenant. Likewise, route targets, they're all auto-generated. And you need a common MAC address, floating MAC address. So here we have a MAC address. And you see there are two different group members we have. One for VLAN, I think 141. Let's see the table here. Yeah, VLAN 141. This is the VNI. And there is another one, 140. And this is the VNI, and this is the multicast address. So we say this is the layer 3 address, which will be used as the floating IP address. And this will be the MAC address for VLAN 141. Sorry, this is for VLAN 140. And for VLAN 141, here is the IP address. This layer 3 interface is also member of that same tenant. Only then the inter-VLAN routing is possible. This is done. And now there is another VLAN called interface VLAN 999. I think this they are going to use it for layer 3. Let me go and check the table. Yeah, it's for layer 3. No, it's layer 3. Just see, this is going to be the source address. And this is going, this 140 is going to be the source, 141 is going to be the destination. This is just an intermediate. Instead of using, see, whenever I want to go from 140 to 141, instead of putting this VNI, I want to put one common VNI. That's the purpose of this. IP address is not a problem here because IP address is not going to be used in the VXLAN fabric. It is the VNI number that is going to be used. So if I use different VNI number, there are chances that going path and coming path will be different. If the VNI number is same, different, if I go from this VNI to this VNI, meaning one of the computer in this subnet going to one of the computer in another subnet, then the path taken, let's say it is A. Path taken is A. And when I go from this VNI to this VNI, see the destination VNI is different now. Earlier it was 141, now it is 140. There are chances that path will not be A, it will be different path, B. So packet goes via one path and returns via another path. This is what asymmetry. To avoid this asymmetry, whenever 140 subnet talks to another network, instead of giving that network's VNI, it will give this VNI. So why there is need for IP address? No need. It is just to cross over. The border crossing மெக்சிகோக்கும் யூஎஸ்க்கும் போனீங்கன்னா பார்டரில் போனீங்கன்னா இங்கேருந்து மெக்சிகோ பக்கம் பார்டர் கிராஸ் பண்ணிடுவீங்க. இங்கே எல்லாம் இப்போ செக் பண்ணுவோம், கஸ்டம்ஸ் செக் பண்ணுவோம், இமிக்ரேஷன் எல்லாம் பேப்பர்லாம் செக் பண்ணிட்டு அனுப்பிடுவோம். இந்த இடம் இருக்குது பாருங்க, இந்த இடம் தானே திருப்பி இவன் செக் பண்ணுவான். அதே கஸ்டம்ஸ் அதே இமிக்ரேஷன் செக் பண்ணுவான். காரில் பைக்கில் எல்லாம் போனீங்கன்னா இது ரெண்டு பண்ணுவாங்க. அப்புறமா நாட்டுக்குள்ளே போயிடும். இந்த இடம் தான் இது. சும்மா இங்கேருந்து இப்படி எக்ஸ்சேஞ்ச் பண்ணிக்கிறது ஒரு நாட்டிலேருந்து இன்னொரு நாட்டுக்கு. இந்த இடத்துல நீங்கள் எந்த நாட்டுக்காரனே சொல்றதுக்கு முடியாது. So the packet comes from this and goes to this, but this is an intermediate exchanging place. When you are coming from this side, you are Mexican. But here, nothing. Neither Mexican nor American. But when you cross this, then you become an American again. So we need an exchange place, intermediate place. That is what? This 50, 90, 999. Question, please. I'll take you again back to that same configuration. Go through this and see what you don't understand. See, you put a command called IP forwarding here. The routing, that's all. The source and destination address is already there in the packet, so there is no need for an IP. Now this configuration will go on every leaf, no change. This configuration you just copy and paste. All the leaf will have same floating MAC address, same floating layer 3 address for this VLAN and layer 3 address for this VLAN. We call it as pervasive gateway, floating gateway. See, have you done VRRP, HSRP? Okay. When you do VRRP or HSRP, you give a floating IP address, isn't it? Now that IP address will be common on both the gateways. Same way, if you go and check, even the MAC address will be same. That is what VRRP MAC address or HSRP MAC address. Have you seen that? You have not seen? Floating IP you only configure. So you know it very well. But if you go to the computer and check the MAC address, it won't be the MAC address of the router. It will be the MAC address of VRRP. Why you know? If it is not like that, then there will be a problem. You see, if this computer learns the MAC address A, now if this goes down, what is the MAC address of the gateway? A only. Packet will be still going here. According to HSRP, when this goes down, you need to go to this side, isn't it? But if your layer 2 address is the real router's address, then problem. So how HSRP VRRP is designed, when an ARP request comes for that floating, let's say 100.1.1.1, this is a floating IP address. When ARP request comes, HSRP will give its MAC address. So that will be here as a MAC address for 100.1.1.1. Now when this router fails, that same MAC address, this guy will respond. IP address will be 100. So you no need to change here the ARP table. You no need to send a new ARP. See, if you don't have this concept, then ARP request should fail, and then it will do again ARP for this address, learn this MAC address, and then forwarding the packet. It's going to be a very long time. ARP table should time out. To avoid that, we have a floating IP address as well as MAC address in first hop redundancy protocols. This is also same like that. All the leaf will have same MAC address. Why? So that even if one of the leaf in case if I have another condition, I no need to have different MAC address now. Same MAC address. Not only that, you see, the idea is this. Here I have VLAN 100. What is the gateway? Let's say 111.1.1.1. Here also I have VLAN 100. For gateway, it need not to come to L1. Same 1111.1.1.1 will be here. And the MAC address will be same. Leaf 1, leaf 2 will have the same gateway, same MAC address. Even this guy, 100.1.1.1, but the MAC address will be alpha alpha. And it is using the VNI, the packets are going to be moved between this. All right, so 5555, a destination A, it goes to L1. Here, 5555, destination C goes to L3. The VNI is same. So the path taken is going to be same to reach and get back. Anything else you didn't understand? Mm-hmm.